In our first lecture of second chapter named Solution, we are going to discuss about solutions, type of solutions and units of concentration. Before we go in the detailed study of the chapter, a certain terms have to be defined and understand which are going to be very important for us in the chapter. The first term, that is, what is meant by solutions? Solutions are homogeneous mixture of two or more than two components. Solutions are made up of solute and solvent, which are completely mixed in one another with equal distribution. The second term, homogeneous mixture. Homogeneous mixtures means the mixing of compositions and properties of the solution which remains same throughout the mixture. The third term, that is solvent. The component that is present generally in a large quantity in the solution is known as solvent. The physical state of the solution is determined on the basis of solvent. In every solution there is only one solvent. The fourth term, that is meant by solute. One or more component present in a solution other than solvent are called solute. In this chapter, we are going to study properties of binary solutions only. Binary solutions means solution in which there is only one solvent and one solute. On the basis of physical state of solute and solvent, the solutions are divided mainly into three types, and each type is furtherly divided into three types each. That means we can say that there are totally 9 types of solutions which are classified on the basis of physical state of solute and solvent. Different types of solutions are summarized in the table. The three main types of solutions are solid solution, liquid solution and gas solution. The physical state of solutions mainly depends on physical state of solvent. As on your screen, you can see that physical state of solution and physical state of solvent are same. Hence, the subtypes of solutions depends on the physical state of solute. As in the table on your screen, the solid solution is furtherly divided into three types. Solid solute in solid solvent. When any two or more metals are mixed together to form an alloy is an example of solid solute in solid solvent. Generally, the mixing of two metals are termed as alloys. The second type is liquid solute in solid solvent. When mercury, which is exceptionally liquid metal, dissolves into metals, it forms amalgams like zinc amalgam or sodium amalgam. This is an example of liquid solute in solid solvent. Gaseous solute in solid solvent. When oxygen gas reacts with a metal to form metal oxide, it is an example of gaseous solute in solid solvent. Similarly, the second type of solution, that is liquid solution, is furtherly classified again into three types based on the physical state of solute. Solid solute in liquid solvent. We know this example, salt or sugar that is dissolved in water. Liquid solute in liquid solvent, that is alcohol dissolved in water. And the third type is gaseous solute in liquid solvent, that is when CO2 gas is dissolved in water, which we termed as aerated drinks or soft drinks. Similarly, third type of solution is gaseous solution, which is also furtherly divided into three subtypes on the basis of physical state of solute. Solid solute in gaseous solvent is when camphor or naphthalene balls gets vaporized in air. Liquid solute in gaseous solvent, that is water gets converted into water vapor and mixes in air. Gaseous solute in gaseous solvent, that is mixing of two different gases like oxygen and nitrogen, or argon and oxygen, or maybe any other two different gases. Mostly objective questions will be based on this table, so it is very important to learn the table. The next topic we are going to discuss is about units of concentration. It is one of the most important topics. The units of concentrations are expressed in many ways. Some of them are like normality, molarity, molality, mole fraction, weight fraction, etc. we have studied in standard 11th. Out of them, few units like molarity, molality, mole fractions we are going to repeat again, and some new units like parts per million indicated as ppm, percentage fraction, weight fraction, etc. are going to be studied. In this lecture, we will discuss about molarity, molality, mole fractions and parts per million. In the second lecture, we will study about the rest of the units of concentration. We are going to study about how to express the concentration of the solutions and what is the formula used to calculate the concentration of the solutions. The first unit we will discuss is about molarity. Molarity is defined as number of moles of solute dissolved in 1 liter of solution. It is symbolized by capital letter M. Formula to calculate molarity of the solution is written as molarity is equals to moles of solute upon volume of solutions in liter. If we want to expand this formula, then we know that moles is equals to weight upon molar mass. Hence, molarity is equals to weight of solute into 1000 upon molecular mass of solute into volume of solutions in ml. The unit of molarity is indicated as mole per liter or capital letter M. The second unit of concentration is termed as molality. Molality is defined as number of moles of solute dissolved in 1 kilogram of solvent. It is symbolized with small letter m. The formula of molality to calculate the unit is written as molality is equals to moles of solute upon mass of solvent in kilograms. Its expanded form is written as molality is equals to weight of solute into 1000 upon molecular weight of solute into mass of solvent in grams. The unit of molality is indicated as moles per kilogram or small m. The next unit of the concentration is mole fraction. Mole fraction is defined as ratio of moles of component to total moles of component in solutions. It is indicated by a Greek letter chi, symbolized by letter X. Its formula is written as mole fraction is equals to moles of component upon total moles of component in the solution. Now if we take a solution made up of solute and solvent, in which small letter n indicates moles of solute and capital letter indicates moles of solvent, then mole fraction of solute is equals to moles of solute upon moles of solute plus moles of solvent. That is, mole fraction of solute is equals to small n upon small n plus capital N. Similarly, mole fraction of solvent will be equals to capital N upon small n plus capital N. If we calculate the mole fraction of solution, that is, mole fraction of solute plus mole fraction of solvent, that will be equals to 1. Hence, mole fraction of solution is always going to be 1, whereas mole fraction of solute and mole fraction of solvent will be always less than 1. The unit of the mole fraction is very useful in relating some physical properties of solutions like vapor pressure. It is useful in calculating involving gaseous mixtures. Mole fraction is an unit less. The next unit, it's a parts per million, ppm. Parts per million is defined as 1 milligram of solute dissolved in 1 liter or 1 kilogram of solution is known as ppm. Its formula is written as ppm is equals to mass of solute into 10 raised to 6 upon mass or volume of solution. Its unit is microgram per milliliter or milligram per liter or ppm. In this lecture, we discussed only 4 units of concentrations. Rest of the units of concentrations we will discuss in next lecture along with certain numericals based on them. So make sure that in the next lecture you have pen, paper and calculator with you. Here are some practice questions based on this lecture. Solve them, and if you have any doubts then contact onto the number shown on your screen.